Okay. Hello there. You hear me?
Yes.
Yes. Can you hear us?
I can hear you. Okay. I guess we can get started. So first, I want to thank you all for inviting me to do it this way because we're living in the tail end of a blizzard right now. And, I could not get out of my house even. So, so this is perfect. This is the future. I love this online technology stuff. So let's see. So what am I going to talk about today? Well, as the title says, Charles Darwin and the Web of Interconnectedness. What I'm really interested in here is a little bit of the history of the idea of evolutionary theory. And Charles Darwin did not do it all by himself, right? We all know that what Charles Darwin was doing was building on a philosophical and scientific history of the evolution, although it wasn't called evolution yet, of the changing pattern of life on Earth. And I just want to mention the first guy I should talk about who's really important in this. And this is probably somebody you've all heard of before. So give me just a moment to switch over here. Let's bring this up. Okay, everyone sees the title?
Yes.
Good. Okay. So now I just have to get this thing to work. Why isn't it? Okay, let's see if I can get this to behave itself. Give me a second. Technical difficulties. There's that. I should be able to. Okay. There we go. Still everything looking good?
Looks kind of black.
Yes, it's black with letters on it. That's the way it should be. How about this?
Black.
Letters just black.
The letters are black too.
Uh-oh, the screen is just black?
It's a black cat in a dark room, yes.
Oh, let me see. Let's see.
There you go, yes.
Oh, wait. No, you're saying now it started working. Okay. Let's try this again. All right. What do you see now?
Alexander von Humboldt.
Okay. We're in business then. So Alexander von Humboldt, I got to mention him because he's really Darwin's predecessor. Humboldt was a brilliant scientist explorer who went all over the place. He went to North America, he went to Central America, he went to South America. And what he did is provide this strong empirical foundation where what he did is he went to all these places and he measured and he explored and he systematized everything he saw and built up this picture of how the world works. That he was praised by Darwin in the Voyage of the Beagle and in the Origin of Species as a real inspiration for his work. So this is an important guy. We should all be remembering him. Okay. Is it going to all go black on me again?
Yes.
Yeah.
Okay. Well, let's see if this works. How's that work?
Yeah.
Okay, I'm getting the rhythm of it then. So one of the things that he was trying to address, that Humboldt was trying to address, was the distribution of all these different kinds of organisms on planet Earth. And so, for instance, if we start with England and Europe in general, and you look around there at the familiar countryside, what do you see? You see lots of sheep and you see bunny rabbits. So kind of typical large mammals of that area. And the question was, will we see the same thing elsewhere? Will we discover similar sorts of stuff if we go out and look around the world? And in the early days of the 19th century, that was going on, sometimes to poor effect. That was the era of colonialism. So here's all these people going all over the place, conquering other people, taking their resources, but also doing scientific investigation and looking around and saying, hey, what lives here? And discovering to their initial surprise that no, you don't find sheep and rabbits everywhere in the world. So that was interesting. So let me see if I can figure out how to move here. Oh, it's going to be annoying. Let's do this. It'll go black on us, and it's okay. Then we're back. So for instance, one great example is we're looking for sheep and rabbits around the world. You go to Australia, and what do you find? You find kangaroos and giant spiders that want to kill you. So there's these radical differences in different environments. And that initially sort of surprised people. If God made such a perfect world that's, well adapted for us, we should find sheep and rabbits everywhere. And no, you don't. Okay, then Darwin's going to come along, and later he's going to go to South America. He's going to go to these islands, the Galapagos Islands, I'm sure you've all heard of. And instead of sheep and rabbits there, what he finds is giant tortoises and iguanas. So there's something funny going on. There are questions that need to be answered. Alexander von Humboldt, his approach was, well, let's go to all these places and figure out what's different about them. Let's puzzle out why the world is different in England versus Australia versus the Galapagos Islands. And he came up with his own answers. That there's differences in climate, there's differences in geology. And he sort of argued, well, these creatures are, and he used the word, well adapted to their environment. Of course, Alexander von Humboldt was not an atheist, but he was a secular humanist. He didn't believe in a personal God or organized religion, but he did think that probably what happened here is that there was a creator of some sort who planted organisms in these places well suited to their environment. Okay. Meanwhile, back in England, everybody's trying to figure out what's going on here. And they're putting together these pictures of how life is organized on Earth. And one of the early ideas, this is from no less than Aristotle, was the idea of a scala naturae. That what there is there's a hierarchy that we could talk about. There's a prime mover, that's God. There's the celestial spheres, that's angels, whatever, the universe outside of Earth. And then there's man at the very top. Well, just below God, of course, but the man's near the top. And then you can rank everything. So one other idea that's floating around at this time is what's the cause of the scala naturae? And many people would have said, well, that's just God's design. But there were some really serious big questions floating around. Here you've gone around the world and you've explored all these places and you've discovered these very, very interesting phenomena all around the planet that are different than what you find back home. And so some of the big questions that were asked were, why are there so many different kinds of organisms? Why can't we just settle for sheep and rabbits everywhere? Then when you look at the scala naturae, what you see is this hierarchy of intermediate forms. Why do that? Why have less developed or more primitive forms of different organisms in different places? And then, of course, there's the big question, how did those organisms become so well suited to their environment? And for many people, the comfortable answer was simply to say, well, God made it that way. But as I mentioned, Humboldt was not that kind of God believer. And his answer was to methodically document the differences in these different places. And he argued that diversity was a result of organisms being finely tuned to the geology, climate, and also, of course, other organisms they interacted with in that place. So this is our picture of the world at the time of Humboldt. This is the picture that inspired Charles Darwin when he went out on his grand voyage of discovery. Okay. So we come to Darwin at last. And I got to tell you a little bit about Darwin's background. I like showing this pair of pictures to my students because I tell them the picture on the left is what you were like when you first entered college. So that's our college freshman. And the one on the right is what you look like when you graduate. The one on the right is Charles Darwin shortly after the voyage of the Beagle. So he's a man of the world at this time. He knows quite a bit. And that's one of the things we try to inspire in students is an awareness of the world around them, and they mature and become better informed about everything that was going on. Now, Darwin is an interesting example to discuss with my students because Darwin was, first of all, a med school dropout. He went to Edinburgh and tried to study medicine there and didn't like it. And he quit. And his father was very concerned that he's going to be this kind of upper middle class wastrel who accomplishes nothing in his life. So he insisted, okay, Charles, you're going to go to Cambridge. He was rich. He was well enough off that they could go to one of the most prestigious universities in the world. So he sends him off to Cambridge with the idea that he would become a country parson at some point, that he would learn the religion, Anglicanism, and he would be suited to a life as a country gentleman. That was the plan. Darwin, well, Darwin was Darwin. Supposed to advance here. Yeah, there we go. Okay, so Darwin was Darwin, and he was more of a sportsman. He wasn't initially a very good student. What he liked to do is charge off on a horse with a shotgun and shoot birds out of the sky, go hunting. He also got into collecting beetles. He was very much an outdoors sort of guy, not well suited to sitting in a dark room studying or sitting in a laboratory doing experiments. He was an adventurer. So in a lot of ways, he's more like Alexander von Humboldt than your typical college professor, like me, for instance. So he's doing all this exploration work in the neighborhood of Cambridge. In fact, his specialties, the things he was most interested in, were botany and geology. So he wasn't your classical biologist. He was a natural historian who was broadly trained in lots of phenomena. He couldn't have been a biologist, for instance, because the word biology was only invented around 1800. So there weren't actually any real biologists hovering around there. So he's just doing his thing. He's gonna go exploring as well as he can. And then he gets this invitation to go on a South American journey with Captain Fitzroy. So what does he do? He sits down for his examinations so he can graduate. And this is, again, where I can tell my students, that it pays off to study hard because he graduated the top 5% at Cambridge. So he starts off as a kind of lackluster student who's more interested in hunting and fishing and collecting beetles. And just by pure inspiration, being really involved in his studies, he goes on to become one of the top students at Cambridge. And he lands this trip of a lifetime, where he's going to go off and join a British expedition to South America. So there's Captain Fitzroy. There's his ship, the Beagle. This was a real deal, right? He's just arranged to go on this tiny, cramped ship with lots of other people. He's not essential crew. He's brought in as a gentleman accompanist to the captain. He later evolves into the ship's historian. He also has to pay for the privilege. It's cost a lot of money. Some of the scholars of Darwin have pointed out that the cost he spent on this 5-year voyage was roughly equivalent to buying a modern upper middle class house. So his family sunk a lot of money into this. He was very privileged to be able to do this. Okay, so he's going off on this voyage. He's going to South America. The ostensible purpose of this voyage is to navigate and map out the South American coastline. And Fitzroy brought him along to do this, to keep him company while he's doing this very demanding job. Fitzroy turns out to be a rather unpleasant character. They don't get along very well. And on top of that, Charles gets grossly seasick the entire trip, and he never quite gets over that. So he spends a lot of the time on the ship, seasick and bickering with the captain, which is not such a great situation to be in. So they get to their destination, South America. So let's bring that up. Oh, well, eventually we'll bring it up. There we go. So the entire purpose of this voyage is to explore the coast of South America. He is supposed to go out and do a mapping journey and figure out where all the ports and harbors are, and where the shoals are, where the dangers and the good harbors are. That's the entire purpose of this voyage. Captain Fitzroy, as I mentioned, is kind of a weird guy. He's got all kinds of problems. He's obsessive compulsive, for one thing. So he turns this into a 5-year trip around the world, kind of exceeding what he was supposed to do. And he spends an awful lot of time cruising up and down the coast of South America, far more time than anyone expected. He actually got into trouble when he gets back because, yeah, he kind of went beyond his brief. Darwin, though, was in his element. He was doing that Humboldtian science. So what he often found convenient, it's kind of shown on this map, is when the ship would put into port in some place, he would get off the boat, he would rent a horse, get a couple of people to join him, and then he would go galloping off into Uruguay and Argentina and Tierra del Fuego and eventually Chile. So he took advantage of this to go inland and explore and just go galloping all over the place. It's really impressive. He was off for long periods of time, as you can see in this list on the map. He'd go off for a month or so, a week, whatever, and just ride hard with the vaqueros exploring the inland part of South America. He actually spent about 2 years doing nothing but exploring South America. From this work, he's going to become the foremost European expert on South American geography and botany and zoology because of all this work. So he's going to explore this continent as well as he can at great personal cost. This was hard work. I'm really, when you read The Voyage of the Beagle, you come away feeling deeply impressed with this young man who is taking advantage of this opportunity and just exploring everything. A real follower of Humboldt. Okay, what does he find? Well, I'm not going to go into everything he discovers. He's exploring the place. He's learning all kinds of things. But he comes away with a deep knowledge of the flora and fauna of South America. So just as one example, here's a green iguana they discovered on the western coast of South America. Well, he didn't discover it. They were common all over the place there. These are spectacular animals, these brilliant green and red animals that live in the jungles of that area. So he's discovering all this stuff. He's documenting it. He's writing it up. He's shipping specimens back to England. He's laying the foundation for a real career as an expert natural historian. But what does he do next? Well, this is the part everybody knows about, okay? Everybody knows this bit, that what he did is he sailed off to the Galapagos Islands. The ship wasn't supposed to go here, first of all. I mean, Fitzroy was supposed to explore the coast. He wasn't supposed to go sailing off to this remote equatorial island, but he did anyway, in part to forage for supplies and things like that. Darwin spent a grand total of 2 weeks here. And this is all anybody remembers of Darwin's voyage of discovery. As I mentioned, he spent most of his time in South America, becoming intimately acquainted with what's going on in South America. And then he goes to this island far to the west, 1,000 miles to the west of South America. And they spend only 2 weeks there. And Darwin does his usual thing of galloping all over the islands, shooting birds, collecting specimens, looking at the world around him. And then again, once again, you notice one of the things he discovers here that he gets really excited about is this. So I've been to the Galapagos Islands. This is a little group of friends that I voyaged to the Galapagos with. Some of you may recognize George Hrab there. There's a guy in a straight jacket. I know that's weird. He was an escape artist, but he wore that straight jacket everywhere. Anyway, so we're down there on the Galapagos Islands exploring, and these are the famous Galapagos iguanas. Now, a moment ago, I showed you the South American iguanas, right? These brilliant green and red, large animals that live there. They live in the forests, in the jungles. Here, these iguanas, they look distinctly similar. I hope you agree. They've got a lot of the same characteristics of the South American iguanas, but they're a darker color because they're largely living on volcanic rock, which is dark in color. So they kind of blend in with their surroundings better than if they were a bright green. And they also forage on algae off the coast. These are swimming iguanas. They've got a number of adaptations that make them distinctly different from the mainland iguanas. So that's something that Charles Darwin noticed right away. He also thought these were really ugly, horrible creatures, but still very interesting. So what he sees right away is there's an affinity between mainland iguanas and these iguanas that he's finding on this remote island. They're different, yet also similar. And this is a key thing in Darwin's theory, is that here we've got this diversity that's been generated somehow, that these are finely tuned in the Humboldtian sense to their environment. But how did that come to be? All right, he's also exploring, and he discovers other creatures. Like if you look in the highland areas of the Galapagos Islands, which are lush and tropical and very leafy green, you find these creatures. This is the Galapagos tortoise. So there's something else that's different. Remember, I mentioned earlier that if you go to England and you look around, take a train trip in England, what do you see? You see sheep everywhere. Go to the Galapagos and you don't see sheep anymore. You see tortoises. So they're kind of adapted to similar sorts of places. These are the browsers of the Galapagos Islands. So that's very curious. Why are they so radically different? Also, of course, Darwin spotted what are now called the Darwin finches. It's kind of a misnomer because when Darwin was exploring the islands, his method of collecting was to bring out a shotgun and blow these out of the sky and then preserve their skins and send them back to England. And it was only later, after he returned to England and an expert ornithologist looked at his birds and he said, these aren't all the same. These aren't all just one kind of finch. There's multiple species here. So this is a lesson he learned is listen to the experts. They will tell you what you're going to find there. Okay, so Darwin, he's out there exploring. He's collecting. He's getting all this data. He's noticing similarities and differences between organisms in different locales. He spends 5 years sailing around. They go to Australia. They go around the Cape of Good Hope. They go everywhere. And he finally gets home, and he's going to settle down. So how does he settle down? Well, he comes from an independently wealthy family. He makes sound business investments. He's got a fair amount of money. And he buys this lovely home in the Kentish countryside. This is Down House. Again, it's a tourist attraction now. You can go there and visit it. It's a lovely home. The upstairs has been turned into a kind of museum. So you can see a lot of exhibits about what Darwin did, what he discovered there. The downstairs, they've tried to restore to the periods when Darwin lived there, but it's well worth the trip. So Darwin is going to spend his time there exploring the data he collected. So at first he spends a lot of time studying barnacles. Again, it's Humboldtian science that he has collected all this data. He's collected all these specimens. He's brought them back. He's made contact with scientists around the world and asked them to send him more specimens. So he's sitting there in this lovely home, the recipient of frequent mails from all around the world where they're sending him more specimens. Like a good, serious scientist, he spends a lot of time analyzing that data and working through exactly what was going on in this collection of data that he's got. So that's wonderful stuff. This is an admirable way to do science, is to do your exploration, do your adventuring, take risks and challenge things and collect lots of evidence, but then spend some time seriously, soberly thinking about it in great detail. And then also another important aspect of the science is communicating. So as I said, he's getting all this mail from all around the world that allows him to figure out what's going on. And he's also sending out mail. He has got worldwide correspondence where he's talking to other scientists in the Americas and Asia, everywhere, in Africa, and communicating his ideas to them, getting their ideas back. So again, I use this as a good example for my students is, yeah, you're going to mature a lot as you go through college. You're going to learn a lot. And the critical things to remember is communication is an important part of science. Take advantage of it. Communicate with everybody. So he's busy working away. He's formulating these ideas. He's trying to pull it all together and explain similarities and differences between, for instance, iguanas in the mainland and the Galapagos Islands, and trying to come up with an explanation for this. And the Humboldtian explanation is great, that there are differences between these environments. So, hey, that could explain why they're different, but it doesn't explain how. And as we all know, the great insight that Darwin provided is to realize that there is a mechanism, that it's natural selection and also sexual selection. That what's going on in these different populations is that they're constantly changing over time. He comes up with this theory and he keeps talking to people. He's sharing these ideas to some local people like Huxley. They're constantly swapping these ideas. He's working to persuade Huxley that this is a good explanation for why these are different. And then he's still getting all his mail. And among the mail that's coming in through his door is something from this guy. Yeah. So he's not alone here. Alfred Russel Wallace is also a Humboldtian scientist who's been exploring Indonesia and Malaysia, working on the islands there, doing the same thing that Darwin was doing, collecting specimens, looking at differences between different islands, trying to come up with an explanation for what's going on. And Alfred Russel Wallace independently comes up with this idea of natural selection. So again, this is another reason to have all this communication going on, is you want to know what's going on in the world around you. You want to share ideas with other scientists. And that's exactly what was going on here. But at the same time, there's the risk, because suddenly he discovers that he has been scooped. He's been sitting on this idea for years. And he suddenly learns that Alfred Russel Wallace has also independently discovered this. So what does he do? Well, if you were unscrupulous, the kind of thing you could do is immediately rush your work into print before this guy gets it out. Instead, what Darwin did is he invited Wallace to co-present papers on this subject to the Royal Society, so that Wallace would also get credit for this brilliant idea. I suspect it also helped that Darwin kind of liked the idea that somebody else also shared this idea, that it wasn't just him sitting alone in down house coming up with his crackpot idea. It was other people that were coming up with it. So this was an idea that was in the air at that time. So he sits down and goes through his notebooks, and he assembles a complete version of his theory. This is the famous diagram from his notebooks. It's where it says, "I think," and then he draws a pedigree, a branching tree of the history of life. And that's kind of the key word here. This is what he is going to add to Alexander von Humboldt's ideas, is in addition to collecting data and showing evidence for your idea, he's also going to make the point that another key factor in the history of life is that it's constantly changing, and there is a history behind this. That one of the reasons animals are different in the Galapagos Islands versus the English islands is that they have different ancestries, that a different history led to organisms adapting in different and unique ways in each of these sets of islands. Okay. So let me wrap this up. So what's the story that's emerging for this? I gave you a bunch of questions at the early part of this talk. And here I'm going to give you the big answers, the big general answers that we could spend an hour or two talking about in detail, but I'll spare you all that. So one question is, why are there so many different kinds of organisms? And remember, Humboldt came up with the idea, well, they're adapted to their environment. The mechanism of that adaptation wasn't necessarily clear, but Darwin is going to provide a key step. And he's going to say, well, it's a product of their history. What animals first populated those islands, how they adapted over time to that environment produces different outcomes. Second question I prompted was, I'm going to answer this in a complex way. I've only got one answer there, but it's more complex than that. Why are there so many intermediate forms, the Scala Naturae? And one answer is that the Scala represents the history of these organisms. And there were many people who adopted this wholesale. For instance, Haeckel, Ernst von Haeckel, would take this and extrapolate it to an extreme degree and say that the Scala Naturae represents an embryological history of life on Earth, which is not true. And that is not currently accepted. Yes, it's a portion of history, but if you talk to scientists nowadays, they will simply reject the whole idea of the Scala Naturae. So one simpler answer would be to say, well, there isn't such a scale of existence, but we are seeing that the distribution of forms on Earth partially reflects their history, and that's why it gives the appearance of this scale. And then the big question is, how are organisms so well suited to their environment? And the answer there is, again, adaptation. It's different environments, different climate, different geology, all these sorts of things conspiring to impose different forces on different populations. And it's their history of adaptation that leads to changes in the form of these organisms. So together, if we want a complete answer, we would take Darwin and Humboldt's answer. And I think Humboldt deserves a lot of credit for changing the environment of science at the time, in addition to Darwin's revolutionary idea that it's a combination of chance, history, environment, and continuous change, that organisms are not static, populations are not static, everything is changing over time, that led to this big answer. Okay, so let me stop babbling at you there, and I would like to welcome questions from everybody. Hello there.
Oh,
Anybody have any questions?
It's okay if you say I was so masterful in my presentation that there were no questions left to answer. That's never true. Yes.
It's not directly related to your presentation. Can you hear me okay?
Yes, I can hear you.
Okay, well, thank you, first of all. So my question is, Darwin wrote in Origin of Species about cats eating mice, which eat bumblebees, and that affects the distribution of flowers in the neighborhood. Did I get that connection right? I think that's...
Well,
So-
he had a more complex answer than that.
Yeah.
Yeah, the big metaphor that he used at the end of the Origin was the tangled bank, where you have all these species fitting together in mutualistic interactions, some of which were predatory, of course, but others were cooperative.
So did Humboldt, did he give similar examples, maybe of that food chain or specific threads like that?
Yes. One of Humboldt's big themes was the complex interactions between organisms and their environment, where the environment includes other organisms. So I would say that Darwin did not come up with the tangled bank metaphor entirely on his own. He owes a lot to von Humboldt, who also came up with similar ideas about how life interacts to produce the complexity that we see. Yeah, von Humboldt's a great guy to go read his books, that if you can find them. He wrote a great, they tend to be rather flowery in their language, but if you like Darwin's Voyage of the Beagle, you will love Alexander von Humboldt's books. And he's got a bunch of them out there. I kind of expect you can find them on things like Project Gutenberg. They're sort of very detailed, meticulous travelogues explaining the different environments that you find in different places. I would also add that we Americans owe a lot to Humboldt because the prevailing notion at the time he started writing was that America was a primitive land full of savages and crude, ill-formed creatures. And von Humboldt actually changed that and pointed out that, yeah, the America is a really interesting place, just as interesting as Europe, and gave lots of stories about how life is sophisticated everywhere. Okay, I saw somebody else raise their hand.
Yeah, one of the things that interests me about Darwin is that he was popular. He had an audience. What was it about the time he was living in England, the people who were reading books at that point, that created an audience that was receptive to hearing what he had to say?
Okay, you're breaking up a little bit there, but you're saying that one of the things about Darwin is that he was so popular? Is that
No,
correct?
not necessarily that he was so popular, but at least that some people were willing to listen, which is interesting.
Oh yeah, no, Darwin, and literally Darwin was popular. Darwin was hot stuff. His books were bestsellers. These were books he wrote as scientific treatises, well-written scientific treatises. They weren't dry and boring, but they were selling these things in library stations. And there was this famous lending library that was going on at the time, where you could mail off and get, by subscription, get books delivered to you. And he was really hot. He was a #1 best-selling author in many ways. Maybe not quite competitive with Dickens, but still really well-known and well-read. There were a number of forces behind that. Education was considered important. I wish that were true in the United States nowadays. But there was a lot of interest in informing not just the aristocracy, not just the elites, but labor would consider it an obligation to be informed about the world around them. And Darwin was a window into this world. He provided them with an opportunity to learn about what science was saying, and they greatly appreciated that. I think that would also be true in modern America, that we find that science popularizers are well regarded, and there's always an audience for their books. Things like Carl Zimmer. It's not, Carl Zimmer isn't quite as popular now as Darwin was in his day, but he's still pretty darn popular, and he gets a lot of attention for his works. Not as much as he deserves, but it's there. So a lot of think also Tyson and a lot of it's on television now. But Tyson and Attenborough are all great science popularizers who reach their audiences in the same way that Darwin reached his audiences in his day. Yes.
Thinking about the idea that organisms adapt to their environment. Our environment has changed drastically just within the last 100 years. What types of things would you give real credence to with regards to the evolution of humans in our current environment? I mean, will we continue to see those types of adaptations?
So that was breaking up a bit, but your concern is about about adaptation and changes in the environment, and you're asking how that's going to affect humans.
And with the introduction of technology within our environment.
Right. Oh yeah, this could be politically charged here. Yeah. One answer, the simple answer I could give you is we're all going to die. Sorry. With global climate change, if we don't do something about this, we're in big trouble. It's going to change our environment so radically that we can't thrive as well anymore. And this has been the history of life on Earth: is radical changes in your environment tend not to favor the status quo, and humans right now are the status quo. But another point you brought up is, what's the role of technology in this? In part, technology has been disastrous, but in another way, technology could help us recover. That one of the concerns here is we got all these people on the planet. One concern is, how will we survive? How will we feed all these people in the face of changing environments that are destroying agriculture, or will destroy agriculture, that are destroying the oceans, that are destroying coastal regions? And yeah, one great hope is that we'll adapt, we'll cultivate technology that isn't so destructive. So things like green technology to generate energy, solar energy, wind power, all these things other than coal-powered plants is one way to get around that. But other ways are things like GMOs. And this is where I often encounter conflict, because I am gung-ho for GMOs. I think GMOs are great because they do provide a way to directly transform species that we rely on for instance, crops. They do have hazards, but they're less hazardous than other methods of generating variance in populations. So yeah, sometimes people want to argue with me about that, especially because I'm one of those left-leaning liberal types, and there's a lot of pushback from those groups about things like GMOs. But I would welcome your input, any criticisms that you have to offer. Yes, in the back. Oh.
Follow up on that question. Last year, the International Commission
Say,
in the three H's, are you in favor of the proposed Anthropocene epoch? And if so, what would be your point of demarcation?
Okay, I'm asked if I'm in favor of what again? It was breaking up a bit. Can somebody
designating an Anthropocene epoch following the Holocene?
Anthropocene epoch.
the
The Anthropocene.
oh, the Anthropocene idea that, yeah, that we're in the midst of a great change in the environment. I don't want to say I agree with it, because in some ways it's absolutely horrible. But yeah, I think it's a genuine thing that, right now there's so many humans that we are warping the shape of our environment to an extreme degree. One of the things that really troubles me, for instance, is the recent news that there's occurring a great die-off of insects. And once upon a time, the comfortable notion was, well, this is the planet of insects. Insects dominate everything, this as far as animals go. So insects are kind of the defining characteristic of the biota of planet Earth, and we mere humans could not possibly be perturbing them. We're more likely to be at risk for being eaten by insects or having our crops eaten by insects. And I think that notion is changing fast as we realize that insect species are dying off at a terrifyingly remarkable rate. So that is one of my major concerns, is when humans are so ubiquitous and so potent in their effects on the environment that we're starting to severely affect, the dominant animal species, animal phylum on planet Earth of the insects. That's something to be afraid for. In fact, it's kind of shaping my research right now, as I've recently undergone a major shift in what I do in research, and I'm gearing up to do a study of spiders. And one of the things I'm arguing is that spiders, as predators of insects, are going to be extremely sensitive to these kinds of fluctuations in insect populations. And I should have started this 20 years ago. Somebody should have started this 20 years ago, but we should be looking in our local environments and just asking, what's the effect on spider populations? Can we measure that and see perturbations occurring at that level? And are they going to change in the future? So yeah, I agree with the whole idea that we're in the Anthropocene, and we've got to start looking more carefully. I could even argue it's kind of a Humboldtian thing, is the environment's changing. Let's start looking at species and ask what's happening to them.
Would there be an effect of population dynamics on the climate change? Like, in other words, with the changes kill off enough people that then there won't be enough people to make the environment worse? So it might actually be
Your question is, could we have a change where there's not enough people?
To make it worse.
Yeah.
To make, well, there's two levels of question there. One is there a threshold for maintaining our current level of technology? And if the population drops significantly, do we start losing technology? Do we start slowing our accumulation of technology? Does science slow down if there aren't enough people? And yeah, I think that's kind of true. But the way I feel about that is, right now, we do not exploit our population enough. That if you have a country that's got widespread poverty, where there's a denial of opportunity for education for large numbers of people, I would think that if we reduced our population and at the same time reduced inequality in economics and provided more opportunities to more people, a larger fraction of the population, that would offset the problem. So yeah, there's a balance to be struck here. And right now, I think the balance is leaning far too much towards exploitation, which makes the expense to the environment much greater than it needs to be, and that we could reduce population and be just fine. Another question is, would the whole thing fall apart if because right now we're kind of a linchpin species on this planet. We're kind of essential. We've integrated ourselves into every single environment. Would that be a catastrophic loss if we suddenly reduced the number so much that we disappeared from various places? And honestly, no, we would. Those environments would thrive so much better if we reduced the population. If we basically just said, for instance, there was talk for a while of the Pleistocene rewilding. Have you heard of this? The idea that, hey, if we just removed everyone from places like the upper Midwest, let's just shut down North and South Dakota. right? Get all the people out of there. And first of all, just let it go back to wilderness, and then repopulate it with bison and all those species that we drove out and exterminated. And maybe if we're really ambitious, we do a Jurassic Park style technology, and we bring back things like ground sloths and rhinos and camels that used to live in North America, and we repopulate with that. It's an interesting idea. It's really impractical. Nobody's going to agree to it. But if it were to happen spontaneously, you know, North Dakota, South Dakota are all sort of, everyone's drifting towards the cities, and they're denuding the landscape of humans anyway. Maybe it would be an interesting experiment. I think that they're kind of missing the point that all of these species are interlinked. This is one of the lessons I'm trying to give you in this talk, is everything ties together, and just trying to restore, you know, a couple of species isn't enough and might cause greater disruptions. So, but it's still an interesting idea. Any other questions? You got me. I'm a college professor. I can just talk and talk and talk. You'll have to draw a line somewhere and say, shut up and go away. Politely. Okay.
I think we missed some of the commentary there. I think we don't have maybe enough lag. We're trying to catch up with you from our Wi-Fi. So hopefully, it looks like I've got it streaming live on my tablet. So I think when we go back and look, I think it'll come across just fine.
Okay, I got the message that something was breaking up and you were missing something, but you were breaking up and I was missing something at the same time. So maybe someone can come up towards the microphone and echo that back, and so I can get it a little more clearly. Okay.
So I think we were breaking up. Is this coming across more clearly? Or is
yes, with you right there, it's much more clear.
Okay, so we missed the last bit.
The last bit where I was saying we could stop anytime.
Okay.
I'm happy to talk as long as you want, but if you want to move on to something else, that's fine with me too.
Anybody else have any other questions?
Yeah.
Oh.
Yeah. There seems to have been some inevitability with Darwin's finding, say, over the next 20 to 30 years. Someone might have come up with his theories.
Okay, so can I have somebody repeat that right into the microphone?
Yes.
Okay.
Yes, it seems as if Darwin's finding would inevitably have been found by someone in the next 20 to 30 years, even if he hadn't gone on that journey.
Yes. There's a sense of inevitability to the discoveries here. As I mentioned, Wallace independently came up with this idea, and I'm sure others would have followed suit. That as data was accumulated and people were thinking about it, it was kind of a necessary thing that was going to happen. Similarly, if you look at the history of genetics, that Mendel was an early outlier. In 1865, he published his book, his paper on Mendelian genetics, and kind of languished. And then around 1900, like 3 or 4 other people simultaneously stumbled on this and caught on. So there is a sense that that these discoveries were necessary and inevitable, that they were a natural conclusion of the available evidence, and somebody would have come up with them. And that's also a factor in why we should accept them. Is this, Charles Darwin wasn't some wild-eyed crackpot who just spontaneously came up with this crazy idea out of nowhere. These were ideas that were in the air, and lots of people were absorbing them, and they were a necessity going to emerge at some point.
Yeah. Another question. There seems to be less focus on plant adaptations. I was wondering whether it's because with animals you get either they adapt faster or it's more liking.
Yeah, that's a good question. Why were we talking about animals all the time? And there's a kind of anthropocentric bias here that we tend to look more closely and recognize differences in animals more clearly. That plants actually do evolve very rapidly. I would say that plants probably evolve more rapidly than animals because many plants have access to mechanisms of recombination that we animals don't. And so they undergo more rapid speciation in some cases. So plants should be studied more, and protists should be studied more, those single-celled organisms and bacteria. The thing is that I see this in my classes, for instance, as you can show students, a population of cats or dogs or mice even, and they immediately spot the variations. They spot the subtle differences between these different animals. You give them a bunch of fruit flies, and you have to train them to actually recognize these subtle differences because they're not quite as obvious to our eyes. And, I will confess to something terrible. I was trained as a zoologist. I took almost no botany. And so when I see a plant, I see, oh, there's this green thing with leaves. And I had poor powers of discrimination. My wife is much better at recognizing differences in different plants that we encounter on our walks. And she'll point me, oh, there's this species over here. And I'll say, what? It's a plant. Yeah, okay. Whereas me, I can spot differences between insects a lot more easily. So I think it's just our bias as animals ourselves that have led to this difference. But it's, there are people who are actively studying bacterial evolution. Think about Lenski. There are people who are studying plant evolution. Lots of people working on Arabidopsis, for instance, in the lab. All these different forms are all evolving, and all it takes is the ability and the willingness to actually look in detail at them to see it, and it becomes quite obvious. Yeah, I tell many of my students, if you like plants, do more plant science because it's well worth doing.
You said Darwin in his time was a very popular writer, but I mean, this idea of evolution was not well accepted, was it? It's not accepted today by half the population of this country.
Oh, well, America is anomalous. America is a weird place as far as that goes. That no, evolution was widely accepted among the intelligentsia, and also among the general population, that it generated an active anti-evolutionary response among a few deeply religious people, who then began a long-term campaign against evolution, and ultimately were very persuasive. But for instance, read Ron Number's book, The Creationists. He's got a very good book that covers the history of creationism. And what you find, for instance, is that at the turn of the 20th century, that was when these different groups, these different kinds of cults that now control many things, like the evangelicals and the fundamentalists, that all arose in America at that time. And when you read their early literature, it's astonishing how willing they are to accept things like that the earth is old, and that species have changed over time, and that there are species that are now extinct, that flourished in the past. All of that you find in their books. They're perfectly comfortable with this. The difference is that they ascribed a divine mechanism to generating variation. Okay, but they did not oppose the observed reality of how the world works. That was a later change. That was something that emerged in the United States primarily, gradually over time, and it kind of steamrolled over a lot of religious ideas. So the early evangelicals and fundamentalists accepted the age of the earth, for instance. They said, okay, well, you know, we'll accept the authority of God's creation. If the rocks say the earth is really old, then obviously the earth is really old. And who are we to argue against what this physical evidence says? And then what you get is things like the Genesis flood book, you know, that came out in 1961, where it argues quite to the contrary and says, no, you've got to accept the primacy of a literal interpretation of the book of Genesis. And that pair of words, literal and interpretation, together always bug me. But okay, that's what they said. So this is a fairly recent process where religion has hardened its position against scientific evidence. And we are much the poorer for it.
How did Darwin's views on religion change with his discoveries?
Darwin's views on religion were much more complicated than many people think. Darwin, I would say, and Humboldt both shared a sort of deistic view, where they did not accept the immediate intervention of a anthropocentric sort of deity, that they rejected organized religion. So in that sense, both of them would have fit in well with your group. They would have been considered good secular humanists. They would have just also said, well, okay, I can't resolve for sure whether there was a creator or not. Maybe there was some, you know, super intelligent, super powerful being that started it all. Did Darwin's views change over time? Yeah, it's kind of hard to discern, because he was very sensitive to popular opinion, and most sensitive to the opinion of his family, in particular his wife, who was a devout Unitarian. That should tell you right away that there's a big difference between then and now, is that a Unitarian could be regarded as fairly conservative in their views about religion. So he was reluctant to come out openly against it. Darwin wrote a very nice short autobiography that you can find online that is well worth reading, where he admits that he does not accept the dogmatic conventional view of religion, but at the same time, how it really ripped his heart out to have to go against his wife's beliefs. And he was very reluctant to defy those beliefs, that he had a lot of respect for his wife and thought, if she accepts this, okay, I'm not going to argue with her about this.
Anyone else? All right. Thank you very much for speaking with us today, PZ. Appreciate it.
It's been a pleasure. No, it's been great. Like I said at the beginning, it makes me so happy to be able to do this online, especially in February in Minnesota, which is not a good time to travel. Okay, thanks very much.
Thank you very much.